There we go. So first I'm going to talk a little bit about odor itself and a little bit about what mitigation actually means and some various kinds of technologies that are available. I'll talk about vegetative environmental buffers and odor dynamics, just how do trees benefit a livestock producer when it comes to dealing with odor. Talk a little bit about vegetative environmental buffer designs. And then I'll give you a sort of a brief update on the research that we're doing and that is available out there so you can kind of have some science behind a lot of what I'm talking about. And then there'll be time for questions. And actually, I think that this is probably a small enough group that if you have questions as I speak, please go ahead and raise your hand and we'll keep it informal and just go ahead and ask as we go. So let's talk a little bit about odor. There are really four major common pollutants when it deals to when involved with livestock operations, and odor, and I'll talk about that specifically in a moment, is sort of the main talk of today. Dust is a big part of that. Particulate matter, that's what the PM stands for. Ammonia is a gaseous component, and hydrogen sulfide is also a gaseous component. But when we talk about odor, the odors that might be considered a nuisance or a potential problem downwind, what we're really talking about is this. And actually, it's the combination of these two things. So what odor actually is it's a really incredibly complex mingling of over 400 different chemicals that collectively are known as volatile organic compounds. And these chemicals come about through the anaerobic decomposition of manure. And these chemicals, they attach themselves to dust. And to a high degree, as odor moves across the landscape and odor that reaches people downwind, it's dust-borne odor. So it's all of these VOCs collected on the dust moves downwind, and it's detected by people. Ammonia has its own issues, but ammonia is lighter than air and tends to dissipate rather quickly from the site. It causes some longer-term problems. It can be oxidized in the atmosphere, and we've got nitrogen oxide kinds of pollutant problems. But those are a little bit longer term and really not directly coupled to the odor problems. And hydrogen sulfide, we know, actually has a pretty bad odor, but it's heavier than air and it tends to move quite slowly across the landscape. So when we're talking about downwind, half a mile, 2 miles away from an odor source, it really is not hydrogen sulfide that we're talking about. We're talking about this. There are several primary odor sources, and this is probably a review for most of you. Certainly the buildings and their emission sites here, different kinds of lagoons and other kinds of manure storage, that's an odor site. And then land application is a big deal as well when it comes to causing odors and that are described as being nuisance. Oops, wrong direction. And there's really three kinds of approaches to dealing with odor. The first one is you can do what you can to prevent the generation of those volatile organic compounds. And I'll talk very briefly about some technologies that try to do that. Feed additives, manure additives, diet manipulation, those kinds of things attempt to prevent VOCs from actually being formed. Then there are some technologies that are geared towards actually capturing them and destroying them before they're, say, ventilated out of a building. So there's a lot of sort of mechanical bioscrubbers available. There are biofilters that attempt to do that as well. And then, of course, there's the approach where you try to disperse odors after they're already emitted from the buildings or from other sources, and you try to reduce their impact downwind. And so here's some of these very common different kinds of technologies that are available. Many of you might be actually using these. Manure storage covers, composting of manure. There's different additives that can go into the manure. Manure injection is a big deal when it comes to application. Application timing is a big deal. There are aeration systems, so you have not an anaerobic manure system, but an aerobic manure system. Different kinds of digestion. I noticed that there were some vendors that are dealing with this kind of an issue. There's potential for genetic engineering of the animals themselves to deal with lowering different kinds of emissions and so on. Other technologies, biofiltration. Jay Harmon at Iowa State University is doing a lot of research on that. Diet manipulation, oil sprinkling to keep dust down, solid separation, and so on. What I'm going to talk about today is in this sort of category. So filtering air after it's emitted from a source, creating barriers, be they visual or physical, depending on what the perspective is, and then landscaping. And this is basically what we're talking about here as the technology. So the basic goals of using a vegetative environmental buffer, other words for VEBs are shelter belts, windbreaks, these kinds of things. And, you know, these sorts of things can actually be switched up. This is not really a ranking. Visual screening, as I'll talk about a little bit in a moment, is a big deal. Vegetative filter, so that you're actually filtering things that are being emitted from buildings, possibly filtering things that are being emitted from different kinds of storage sources. And then windbreak and shade. In terms of shading buildings, there has been research, not by our particular group, but at other places that have shown that you can reduce electricity bills and so on because of shading impacts. You can reduce wind impacts, and so it lowers your heating bills and those kinds of things. So there is research out there to show that there are some benefits associated with that. But what I'm going to talk about today mostly is this filtering impact and then some of the benefits of visual screening. So I think a good place to talk about how trees can be beneficial in terms of mitigating odor is to talk a little bit about the odor itself again. These are ground level emissions, and due to a lot of really common weather conditions like simple temperature inversions, there tends to be very limited plume rise, and so that those emissions, as it's associated with dust, they tend to stay at the ground level and they move across the terrain. And terrains in Iowa and other livestock producing states, they're relatively devoid of things that are going to cause mechanical turbulence. Crop fields do not cause a lot of mechanical turbulence, and odor just has a tendency to move right across the tops of those. We know that odor comes, lots of different spatial and temporal variability, so the plumes come in different shapes and sizes that happens throughout the year, not just in the summer months, but in the winter months as well. And then again, it's this relationship of particulates and odor. We know that those volatile organic compounds are clinging to particulates. It's by way of particulates that most odor moves downwind. And research has shown pretty conclusively that if you can control the movement of particulates to an important degree, you're going to be controlling the movement of odor as well. And so our research at Iowa State, as well as colleagues at Penn State, University of Delaware, and some folks up in Canada, we've identified a number of dynamics that happen when you use systems such as this in the background. There is definitely a dilution impact. There is the physical interception and capture of these particulates at the sort of the interface of the plant. There is some deposition of the larger particulate matter as it physically drops out of the airstream due to reduced wind speeds. And then a lot is being learned now about how site aesthetics can improve the way that people interpret, the way that they perceive, one, what the farmer is doing to deal with these things, and also just sort of the psychological interpretation of odor. And I'll talk about each one of these in a moment. But first, let's take a little look at sort of what particulates and odor is doing in the landscape as it's emitted from a building. Now, this is a computer simulation of a naturally ventilated swine barn. So the wind is coming through here, it's blowing through the building, it's cooling the animals, it's venting out this building here, and you can see a tremendous amount of particulates are generated within this kind of a system. So this is animal feed, animal dander, dried manure, dust that's being picked up from the fields behind it, dust that's on site, and so on. And what this does sort of physically is it kind of rolls across the terrain like that. And so one big question is, well, what happens if you put some kind of a barrier here? And so here's a different look at that sort of same kind of a computer simulation. And this is what the computer modelers are calling a diffuser type barrier. So they've simulated a single row of trees. And you can see clearly there's a difference here and here. So the question is, well, what sort of dynamics are actually happening here physically? And so this overlay kind of gives a brief description of what's going on. It's not to scale, but you can sort of get an idea of what's happening. And so what happens when wind hits a shelter belt, even just a single row, one of three things happen. Some of it goes through the shelter belt, some of it goes up and over, and then some of it's going to go around the sides where the barrier isn't. Wind tends to go where it's going to be least impeded. So this this sort of impact right here, we've got some air streams going up and over this shelter belt barrier. This behavior can be upwards of 2 times the height of the shelter belt. So if you've got a 30-foot row of trees here, you're getting some wind being pushed about 60 feet into the air. So we're getting some mixing here of this air layer with some air layers up here. So again, we're getting a little bit of mixing here. There is some dilution impact there. But where the dilution is really happening is to the lee of the shelter belt. What happens here when wind comes across the top of any kind of a barrier, the air streams compress and it picks up speed. That's called wind shear. And when wind shear, when that highly compressed airstream sort of goes past that barrier, it starts to expand again, and it starts to break up, and it causes a tremendous amount of turbulence. And so we've got this high turbulent zone right here where what's being emitted from this building comes up and over, and it gets sort of caught up in there. And it allows for a much slower release of these particulates back into the downwind airstream. And so this is really where we're getting a lot of this sort of dilution effect, this dispersion effect as well. We're also getting a lot of particulates actually being physically caught and held at the shelter belt surface itself. What this means is H is these numbers are times the height of the shelter belt. So this is 16 times the height of the shelter belt. So at some distance from the buildings, these dynamics are happening, and you know, start thinking about design issues and optimal locations and the amount of space that might be involved and these sorts of things. And I'll get into that in a minute, but just sort of give you a heads up that there is quite a bit of science and engineering that goes into how we go about giving recommendations for these things. Physical interception of dust. Now this is a picture from a poultry context. Poultry dust shows a lot better on the trees than swine dust does, so I opted to use this photo. But in general, we've done a lot of research showing the ability of trees to grab on and hold on to particulates. We've done a lot of research on the long-term health of trees in these kinds of situations and so on. I'll just give you a quick overview of some of the key details. 90% of the odor particles that are generated inside these buildings are in the size range that are best captured by trees. Odor particles are irregular in shape, and we know that that is better for retention on tree surfaces, so it just doesn't hit and bounce off. It hits and sticks. And it's the whole above ground part of the tree that acts as surface area for filtration. So it's not just the leaves. So if you're thinking about using deciduous trees that drop their leaves in the wintertime, well, there's still quite a bit of woody surface area there that is also grabbing onto and holding onto different kinds of particulates. And then for thinking about the long-term health of a tree that's inundated with dust like this, our research has shown that precipitation to some degree can help wash the tree surfaces off, but then there's also maybe some management that can go into it, periodically hosing things off. We have some producers that have created these misting systems that can keep the trees moist and relatively clean and so on. So we can talk about that a little bit later as well. And then aesthetics and odor perception. This is really the trickiest one to study because this is so qualitative and highly subjective that it's hard to put numbers on these sorts of things. But a lot of research, including some of my own, has shown that in general, as farm attractiveness, and again, that's a subjective concept, but as farm attractiveness goes up, the perception of odor offensiveness goes down. And there's been that's sort of been a research concept that's been studied for decades. And a lot of it's been associated with this notion of out of sight, out of mind, the softening of visual cues. A lot of psychological research has gone into those sorts of benefits. And we also know that these are incredibly visible on a landscape, whereas putting a cover on something like this or doing some sort of manure additive or feed additive, that's not known to the general public. They don't know that that's happening. They don't know what's going on. This is, and to the degree that the public understands what these trees are doing and why they're there, and that it's an odor mitigation technology and those sorts of things, you get some good kind of PR community relation benefits. And a lot of research has shown that those benefits are definitely real and distinct. Some aesthetic focus group work that I did with I did a series of these focus groups in Iowa, and I talked to pork consumers basically, and I asked them, well, what do you think about farmers using trees? What do you think about trees in the Iowa landscape? And definitely a high preference for more trees. Iowa could always use more trees. And a high agreement that shelter belts definitely improve the aesthetics of confinement production. They make the facilities look better. And a high appreciation for the visual response to odor issues. That's sort of things that I was just talking about. So qualitative, but definitely interesting. And if you talk to producers who actually use trees, they'll probably tell you many of the same things. I've done surveys with producers and people of the general public, and they all have these positive responses to definitely doing things, doing the right thing, being a good steward, and then using a technology that people can really understand and respect on sort of an intuitive level. Here's just sort of another simulation of some of the visual screening kind of impacts. A planned facility site, you might put in trees with the building. We're trying to encourage that these kinds of systems are part of the initial plans of putting in a new site. A new facility. In a few years, let's see, year 5, the trees are a little bit bigger. This is red cedar, which is a relatively fast-growing conifer species. 10 to 15, that's actually probably more like 15 to 20, but you kind of get the idea of what I'm talking about from that angle. Get a nice row of trees there. It's definitely doing the physical dynamics that I talked about, but in terms of visual screening, it's fantastic. Other benefits of using vegetative environmental buffers include that it's a legitimately size-neutral technology, so large and small producers can use them throughout their system in various ways. A lot of other technologies kind of tend to work better for smaller producers or larger producers. This one, again, it's neutral. It doesn't matter who you are, what size facility you have. It doesn't matter what kind of technology you're utilizing. You can still use trees. And this is really rather unique, is that it can help with all sources of odor. It can definitely help with the odor that may be coming from the building, that may be generated at the manure storage, and to some degree, and I don't really talk about this a lot, but to the degree that trees can be used as barriers around fields, so fence lines and so on, they can contribute to dealing with odors that are coming off of fields after manure application. So. Definitely, this is sort of a key benefit of using this technology. And it's comparatively very inexpensive compared to other things that you can do. And I'll talk a little bit about costs in a moment. And in theory, it's going to increase in effectiveness over time as those trees get larger and more morphologically complex. Whereas most other kinds of approaches, certainly those that are mechanical in nature, they tend to depreciate over time. And management costs and time keeps going up and up. With trees, in fact, there is quite a bit of management to keep them healthy in the sort of the first few years. But after they mature and they get of certain size, then most of the maintenance requirements simply are just mowing, just for aesthetic purposes. So, it's one of these things. It'll get more effective, and the management efforts and costs will start going down over time. Definitely unique in terms of technology. So a big question is, well, how effective are these things? And, I talk about these being incremental in their reductions to odor. There are no silver bullets. There are no singular technologies that you can use to deal with odor. It's a combination of management strategies and different technologies and different approaches that collectively will help mitigate odor to the point where it's not causing any problems. Our research shows, and these are conservative numbers, our research suggests that vegetative environmental buffers contribute at least within this range in terms of reduced odor downwind, odor perceptions downwind. Now, these numbers were generated in research projects that were very pilot-oriented. They were very small scale. They were dealing with very simple systems. Single rows, maybe 2 rows, and so on. If you had a very comprehensive, complex system, we're speculating that the numbers could be higher. But this is so site-specific. Everybody's facility is a little bit different. Everyone's topography is different. Geography is different. Climate is slightly different. And so it's so site-specific that I can't say, nobody could say 10% your place, 10% your place, 10% your place. It's going to vary. Some will be far more effective than others. Scale has an impact as well. Some of the mid-sized producers can probably deal with their emissions a lot better than some of the larger ones. But then again, in terms, that's the physical side of things. In terms of the aesthetics and so on, everybody can benefit from that probably equally. So what we do is we talk about using trees within a suite of odor management strategies. Trees are not going to do it by itself. If that's the only thing that you want to do and you're not going to put any effort into it, the trees will probably fail because it's not a comprehensive approach to dealing with odor. But it definitely can play an important role. And again, 6 and 10% reduction, maybe 15% reduction. That's a number that Steve Hoff at Iowa State is comfortable with. Imagine adding that into some of the other things that you're doing. And again, it's additive, and every little bit helps. And so this is an important kind of thing that you can do. And ultimately what it's going to do is it's going to lead to reductions in what are called the phytofactors. The frequency, the intensity, the duration, and the overall offensiveness of odor events. And so it's reductions in all of those sorts of things. And it definitely can enhance the ability of the separation distance to do what it ostensibly is supposed to do, is create enough distance to allow for natural dilutions and those sorts of things. So it enhances that. And for those of you who are thinking about new sightings of facilities and are thinking about using some of the modeling that Iowa State University does, these numbers can help adjust some of those sighting things and can adjust your sighting model by about 10% in terms of distance from other neighbors and so on. So it does have those kinds of benefits as well. So planting design issues. This is very, very critical. And I'm going to go over just a couple examples here very briefly. When I am asked to help design one of these things, I first want to know what are the goals of the producer. Is it for visual screening? Is it for legitimate filtration? Are there other reasons why they want to use trees? And depending on what those goals are, I'll create what I call functional zones. And so everything that I recommend to be planted is planted there for a specific purpose, for a specific function. And then, of course, you don't want to create any hazards on site, and we'll get to that in a minute. So basically, if filtration is a key, and let's imagine that this is a naturally ventilated set of buildings, then there are some things you need to consider. One thing you want to consider within the realm of this create no hazards idea is, those of you who are familiar with snow fences and have trees on site, you know what they do when it comes to snow. You don't want to cause snow deposition problems. You don't want to put them too close to the building, and you're going to get a huge dump either on the building or on access roads and those sorts of things. So that's a major concern. So distance often plays a role. Now, I have a minimum 250 feet away from the buildings. This can be certainly manipulated depending on the species, depending on the spacings, depending on lots of things. And I just use this as a generalization to give some producers an idea that, to plant trees, you're going to need some space. But this could probably be shortened considerably depending, again, on what species you use. But you're definitely going to want to count on snow deposition. Another thing that you want to consider, since this is naturally ventilated, you definitely don't want to impede the flow of necessary wind, right? You need to have those buildings ventilated. And so you might toy around with, again, distances from the buildings. At 10 times the height of a mature tree, wind is not going to be impacted. It will be right in here, but by the time it gets to here, it's the same wind speed as it was about here. Toy with the spacings a little bit. They might be tighter here for filtration maximization, but a little bit more open here. This way you're still getting continuity on the site. You're getting some visual continuity and so on. Or you might even just go without having trees on this end. It completely depends on what the producer is most comfortable with, what your ventilation system is, and so on. And ultimately, what are the goals of the producer? You can even have secondary things in here. So this might be a row of shrubs that you would throw in. Just again, as every little line actually helps in terms of filtration and creating some of those dilution impacts. Here's another kind of system, maybe a slightly larger system with a different kind of technology. In this case, we're looking at tunnel ventilation. And we've got 2 above ground concrete manure storages. Again, what are the goals of the producer? Maybe visual screening is a big deal, so you want to have a single row, maybe going all the way around the facility. Maybe you want to have maximum filtration, so you can have different kinds of systems here that are designed specifically to deal with what's being ventilated from the buildings. Now, since these are tunnel ventilated, you can toy around a little bit with distance. You don't want to be too close because you're going to create back pressure and cause the fans to have to work a little bit harder. So, what is that optimal distance? Our research shows somewhere around 10 times the diameter of the fans away from that fan belt area. Still got to consider for snow deposition. Other things to consider, this may be mechanically ventilated, but you still need to have an inflow of air into the intakes to have proper vents. So again, you don't want to completely close off the site to winds that are coming on site, but you can still manipulate things to a degree where it's not going to cause problems in the intake side of things. Other hazards that you need to watch out for is, in and out, trucks coming in and out. Are you going to be impacting the visibility of those roads and those sorts of things? So again, manipulating with species, maybe some shorter species, wider spacings, maybe not even having trees here, just so that the access road isn't going to be a site of problems in the future for trucks, and so on. One thing I didn't actually get into is here's some wind roses for Iowa, and I don't know if that's really quite visible. So let me actually go to the next one. Here's even another little touch that you might have. If these are open topped, you might fancy that you're going to have a row here, and what this does is it prevents winds from blowing over the top of that manure storage. We've got volatile organic compounds are convecting off of that surface, and all the wind that blows across that, all the particulates that are blown across that, are going to pick up all those VOCs and take them downwind. So to the degree that you can prevent winds from blowing over the top of that, you're going to benefit yourself, and these VOCs will just sort of dissipate on site and not be part of the downwind airstream. Here's a wind, what we call a wind rose, and what this is, and this is for the summer months. This is June through August in central Iowa. This is the winter months, December through February in central Iowa. And the bigger this is, the higher percentage of the prevailing winds are coming from this direction. So in the summertime in central Iowa, by and large, winds are coming from the south, the southeast, and the southwest. In the wintertime, it's just the opposite. It's coming in from the northwest, the north and northwest primarily. Got a little bit coming in from the south, but most of it's up here. And again, so let's go back real quick and talk about some designs here. So this was designed clearly for summer winds. We've got winds coming in through the south. We've got zones here. We've got zones here for added protection. A lot of it's coming in from the southeast, so that we're covering those kinds of winds. In the wintertime, we know winds are coming this way, and so we've got that snow deposition zone there too. So again, all these different kinds of design issues that go into it, and we take into consideration prevailing winds. We take into consideration historical climate patterns and so on. So all of that is built into a particular design. And this is from an actual farm, and you can see that, again, they all come in different sort of formats and shapes and building configurations and ventilation systems and so on. And so these things can really be sort of modified to fit whatever they need. This one was sort of unique, and it's difficult to see, but they didn't really have odor problems, but they were definitely having problems from easterly winds. Well, not a whole lot of easterly winds shown up here, but for this particular farm in this part of Iowa, it was a problem. And so they wanted screening here because these vents were having to work overtime in order to compensate for that. So they wanted screening for that purpose. They also, opted to have an artificial screen put in as well, so that you're getting sort of a dual benefit there. One of their problems were they didn't like this open-top manure storage being visible from the road, so multiple layers of potential visual screening and so on for that purpose. Again, it depends on what the producer wants to get out of this system. The systems can be designed for virtually any kinds of purposes. Here's another a producer that was interested, by and large, in visual screening. Had a neighbor up here somewhere about a half a mile away that didn't like to see the new barn. So he wanted visual screening. So I recommended, just on the onset, just a very simple row of fast-growing trees, so that in 4 or 5 years, if you go with an Austree willow or some of these hybrid poplars or something like that, they can grow very fast, very quickly, very densely. Single row here. I also recommended that, some of these species are sort of short-lived. Maybe 15 years they start to break down. Some of these hybrids have a tendency to do that. So maybe have a backdrop of slower growing conifers, so that if this row needs to be removed, By the time that happens, this is going to be a nice, healthy stand, again, for that visual screening purposes. But you can also get kind of unique on some of these things. Maybe there's an opportunity for selling some of this material. So this is just an example. One recommendation could be planting it all to a small grove of silver maple. Well, silver maple stumpage rates are pretty high these days, and so they could actually sell it locally to a mill, put it on a short rotation, and you could earn yourself a small little pocket change there for doing that. You're getting everything you want. You're getting that visual screening, a little bit more maintenance, a little bit more management, but there's going to be a return in the not too distant future. Thinking about bioeconomy issues, maybe thinking of these sorts of things as producing short rotation woody biomass for ethanol production and things like that. That's going to be somewhere down the line when some of these facilities are going to be not looking at just the grain and the corn stover. They're going to be looking at perennial systems and switchgrass and other prairie grasses, but woodies can be a part of that as well. So thinking sort of long term, what can you do with this beyond just the odor benefits and the visual screening benefits? There might be some actual returns potential for using trees on your site. So here's the big deal. So proper site prep is everything. So if you're really thinking about planting trees, you have to go all out. You have to give it 100%, and you have to take it very seriously, because you don't want to plant things that are going to be dead in 3 years. So site prep, I cannot emphasize this enough. If you do this the right way, you're going to decrease tree mortality, you're going to increase the tree growth, and ultimately, and this is the big deal, you're going to reduce the time, money, and effort that goes into dealing with these kinds of systems. And so just to give you an overview of what might be involved, depending on where you are. If it's a retrofit, that might be different. You might be planting into crop fields. That's a little bit different. And if you're a new facility, you're planting onto a construction site. And so these are really harsh conditions for new trees, seedlings, or even older species as well, older tree stock if you wanted to go in that. So, at least, you might do the fall before, and it involves a number of steps. And then you're going to be doing planting in the spring. So it's not just, I'm going to go right out and start planting trees. There are some steps in planting that goes into this. And again, if you do it wrong, there's a high probability that those trees will die. And you might not even know the trees are dying for a few years, because an unhealthy tree has a tendency to look actually pretty healthy over the first couple of years, because it's doing what it can to survive. And then you come to year 3, and all of a sudden there's no leaves, and you find out that your tree is completely dead, but the year before they looked great. Well, that's because there was bad site prep. They were essentially dead for 3 years. It just didn't show until that time. And so, again, when I give recommendations, and I don't give management recommendations, and I don't tell farmers how to go about establishing these things. What I do is I tell them to talk to a professional forestry consultant, and I also tell them to talk to nurseries. And there is a nursery vendor here that has a booth at the Port Congress, and I know that there's someone else out here who also is a nursery. So I'll plug these guys because they came. Kelly Tree Farm, Mr. Kelly is right there. If you want to raise your hand, talk a little bit about trees, different species, different plantings, costs, and so on. And Matt Rolfs is sitting right there. He's also a tree vendor, and he has the booth here on the conference. So again, talk to those kinds of people about the specifics of tree species and maybe what the costs are these days and so on. I can do the design stuff, but I'd leave it to those professionals to deal with the on-the-ground stuff. They can also help you procure stock, planting stock. Different other kinds of options, really simple drip irrigation systems. All you need is a water supply, and the systems come sort of pre-built for you. So pump, filters, pressure regulators, gauges, and so on, main lines. Very simple kinds of systems. A little bit of cost for the water, perhaps, a little bit of cost for the system, but in the long run, this is a relatively inexpensive system. Iowa, by and large, doesn't really need irrigation, but there might be some facilities that do. There might be some initial plantings that could really use water early on, for example. So this is a management system you might find yourself dealing with. Mulching individual trees is a big deal, and I won't go into detail on this. Again, that's for the on-the-ground tree folks to talk to you about. Weed control is often a problem, but this is from a research partner in Delaware. They're looking at different chemicals. They're looking at different individual tree biomats. They're looking at, this is a biodegradable plastic matting that has shown a lot of promise. Relatively inexpensive, despite how sort of complicated it might look. These are things that you need to factor in too. You don't want to plant trees that are going to die. Again, that's what I'm basically trying to say here. In terms of economics, this is a big deal. I did a number of analyses on these sorts of things, and what I did, just very quickly, is I created an analysis that calculated all the upfront costs, and most of those are tree stock, maybe buying the services of someone who's going to do the planting for you. Site prep, planting stock, the actual planting, and the maintenance costs over time. So this would include mowing, this would include dealing with weeds in whatever way you choose to do, and so on. And I calculated all those costs over a 20-year period. And I had two sort of main cost scenarios. The biggest cost is the tree stock. And so you can go from a seedling perspective where the, 75 cents per tree might be reasonable if you buy it wholesale. And a more expensive scenario where every single tree I recommended was at least $11. And so I calculated all the costs and put them on a per pig basis. Seedling scenario over 20 years, and so this is every pig that's produced at that site over a 20-year period. It's about 3 cents a pig. At the higher expense, upfront expense, it comes out to about 33 cents per pig. If you throw in cost share programs like EQIP, it cuts these in half. This gets down to less than a penny on some sites, some facilities, and this goes to about 15 to 10 cents per pig. Compared to other kinds of technologies, this is very inexpensive. If you go with some complex systems that might involve drip irrigation and those sorts of things, you're not even adding a penny per pig. So again, I've done cost comparisons with this and looking at using manure storage covers, looking at additives, looking at all these sorts of things. And this is very competitive in terms of cost. In fact, it's so competitive that it really leaves a lot of money left over, thinking of here's the amount of money I want to spend on odor management. It leaves a lot of money left over in that pot to do other things, to apply other technologies and so on. Very quickly, since we're almost out of time, different research that we're doing here, it's both biophysical, social, and economic. It's multi-departmental. It's not just me in the natural resource department, but we've got the ag system bioengineers involved. We have people from sociology and animal science. Lots of universities involved in looking at this question as well. So this is one of the more, thinking of the future of research in odor mitigation, the benefits of using trees is going to be more and more analyzed. And so we're going to learn a lot more in the very near future about what, the benefits that they can provide.